record the lecture, and now we're going to, I should say, uh, Philip, brilliant PowerPoint's presentation on the radioactive decay with applications to the cancer therapy. Okay, Philip, here you are. Please start.
Didn't share screen.
You do not see that?
No.
Oh, really? So sorry. Oh my goodness. I thought I did it. How about now? You have the screen?
Yeah.
Awesome. So sorry about that. I thought that I just shared the screen before. Yeah, sorry. Please go on.
You can play the video on the right.
Oh yeah. Oh my God. Look at the video. Let me see. Guys, everyone sees the video, which is it also shared with you?
When I need to grow my business, I use
Oh,
Fiverr.
that's
Got a designer for my logo,
advertising.
programmer for my website, writers for my.
Not really.
You do not see the video, huh?
Yeah.
Oh, you see it or you do not see that?
I can't see the video.
You cannot.
Yeah.
Let me stop sharing and share this with the video. How about now?
Oh, you open it.
The video is open. Do you see that?
Yeah, I mean, you can open it on PowerPoint.
Oh, but you saw that also on the PowerPoint, huh?
Yeah.
Oh, okay. Let me do that on the PowerPoint. Let me do that on the PowerPoint.
Just click start, the middle one. Yeah.
Ah, okay. Is it good now?
Yes.
Oh my God, that's interesting. What is this?
It's just I don't know. I
Oh my
found
goodness.
on YouTube.
It's so exciting.
I think it's funny, so I just play on PowerPoint.
Very nice. I wish to be there. Oh my God, that's so interesting.
So radioactive decay. Next slide, please.
Oh, is it fine? Is it enough?
Yeah. Yeah. That's enough.
Oh my God, I was enjoying that. Why should we go to the next one?
Because
Thanks for, it was for changing the mood, huh?
Hmm?
It was a brilliant thing that you put that on the beginning of the slides because it just changed the mood. Thanks a lot.
Yeah.
I wish if you could have watched the whole video, but you said next slide, but no problem. Thanks for putting it there, Philip. I really like that. Oh, sorry, next slide. Let me see. I go to the next slide.
So radioactive decay, also known as nuclear decay, radioactivity, radioactive disintegration or nuclear disintegration is a process by which an unstable atomic nucleus loses energy by radiation. A material containing an unstable nucleus is considered radioactive.
Next slide.
Mm-hmm.
Oh, okay. The picture you have on the far left of your screen, is it a kind of a demonstrations of the radioactive decay?
It just I'm not sure actually.
It's an interesting picture. It seems that we have a nucleus at the lower left, and we have, let's say, a proton. It seems that they combine, if something happens in between, a kind of a reaction. Then we have, let's say, a helium nucleus, 2 protons, 2 neutrons. Then we have a different atom with a different, it seems that it resembles to something which is a kind of a radioactive decay, which this one is going to be the alpha particle radiation, the alpha particle, and also the new nucleus. And also, Philip, I just give you the access to my screen. You want to change this slide yourself?
Yeah.
Yeah, please do that.
It's much easier. Okay, I'm gonna change the next one.
You cannot do that from there?
Yeah, I can.
Should I do that or you do it?
I can't click it for some reason.
Oh.
There's 3 common type. 3 of the most common type of decay are alpha decay, beta decay, and gamma decay, all of which involve emitting one or more particles or photons. The weak force is the mechanism that is responsible for beta decay.
Okay. You know what is, guys? Do you know what is a photon? We have particles in radioactive decay. We have particles and we have also a photon. What is a photon? Do you know that, Philip?
I can do the research now.
Sorry, what?
I mean, I can search on the internet.
Sorry, say that?
The photon is a type of elementary particle. It is the quantum of the electromagnetic field, including...
No worries. I can explain that to everyone. Thanks for searching it. But guys, look at that. When you have the radioactive decay, you have 2 products of the disintegration. One of them is going to be the particles. For example, the alpha particles, which is essentially the nucleus of a helium without the electrons orbiting around it, which consists of 2 protons and 2 neutrons. You have also the beta decay. Beta decay is essentially, as Philip is going to explain about that, is the electrons, high-speed electrons, which disintegrate from the atom of the radioactive materials. And also you have the energy, which is the gamma ray, which is a result of the instability of the nucleus of the radioactive materials. It comes to a more stable position, and as a result, it gives some energy. Imagine that you are tired, you sit back, relax, and you say, "Oh, I'm now fine." And I'm fine, it becomes like the energy which the nucleus emits from itself, which is called the gamma energy, which is a very high energy type of the radiation. But what is a photon? They describe, when you move to university, the photon is a kind of a particle-like, not a particle, of a radiation. In the quantum physics, you talk about the fact that, for example, the radiations, any sorts of electromagnetic radiation energy is inside imaginary particles which are called photons. For example, if you talk about the gamma ray or the visible light, for example, your desk lamp is a visible light. The visible light has an energy. This energy is inside its photons. The photon carries the energy for the visible light. And that's what we mean by the photon. For the radioactive decay, we are talking about the gamma radiation of the unstable nucleus of a radioactive material when it makes a transition to go to more stable position by emitting a radiation as a gamma ray, which we call that also photon, which carries the energy. Yes, Philip?
Yes.
Thanks. Please go on. Oh, you have the access now. Ah, good for you.
Radioactivity was discovered in 1896 by the French scientist Henry Becquerel, while working
That's right.
phosphorescent materials. These materials glow in the dark after exposure to light, and he suspects that the glow produced in cathode ray tube by X-rays might be associated with phosphorescence.
Phosphorescent material. Phosphorescent.
Phosphorescence.
Phosphorescence.
Okay. He wrapped a photographic plate in black paper and placed various phosphorescent salts on it. All results were negative until he used Urium salt. The Urium salt caused a blackening of the plate in spite of the plates being wrapped in black paper. These radiation were given the name Becquerel rays.
And just, Philip, one quick question. What is that? It's a very interesting word. To be honest with you, if you ask me to write it, I cannot spell it because it's a very tough word. Phosphorescence. What is that? Have you heard of that? Have you heard of the concept fluorescence?
No.
For example, imagine that there are some materials. For example, have you seen those kind of materials that it's like the toy? You buy them when you put that, for example, it's a toy. In total darkness inside your room, they glow in red. They glow in, let's say, for example, yellow
Green.
or green. Have you seen that?
Yeah.
Yeah. These are called fluorescence or phosphorescence. It's a kind of materials that it emits electrons in transition, then it radiates back and it gives back the energy. I don't want to talk too much about that because that's very advanced, but it's sort of toys which you see. You put that in your, let's say, for example, bedroom, all the lights are off, but you see a glowing light coming out of it. It's either green or it's red or this is yellow. These are the fluorescence. If the matter which radiates the light is phosphor in a periodic table, they call that phosphorescence. Awesome. Thank you. Oh, call an ambulance. Do you want to play? Yeah. You don't want to play? Oh.
Hey, old man, give me everything.
Call an ambulance! Call an ambulance! But not for me.
So funny. Thanks for including these clips there.
Alpha emitter radiation therapy. Therapy that uses a radioactive substance that gives off a type of high energy radiation called an alpha particle to kill cancer cells. The radioactive substance is injected into a vein, travels through the blood, and collected in certain tissue in the body, such as the area of bone with cancer. This type of radiation may cause less damage to nearby healthy tissue. Alpha emitter radiation therapy is used to treat prostate cancer that has spread to the bones, and it is being studied in the treatment of other type of cancer.
Interesting. Then that's the alpha particle, which is responsible for treating the cancer.
Mm-hmm.
Very interesting. The alpha particle. Very good. Thanks.
Radioactive decay law. So this is the formula. So the radioactive decay law states that the probability per unit time the nucleus will decay is a constant independent of time. This constant is called decay constant and is denoted by lambda.
Lambda, that's right.
This constant of probability may vary greatly between different types of nuclei, leading to many different observed decay rates. The radioactive decay of certain number of odd atoms is exponential in time.
Mm.
The rate of nuclear decay is also measured in terms of half-lives. The half-life is the amount of time it takes for a given isotope to lose half of its radioactivity. If a radioisotope has a half-life of 14 days, half of its atom will have decayed within 14 days.
That's right. And Philip, just one thing, I was curious to see if everyone knows in the class. Do we know what is an isotope? Because being isotope, apparently it seems to me that's a crucial word when we talk about a radioactive material and the instability that a radioactive nucleus has. And that's why it emits, let's say, for example, alpha particles, beta decays, and also radioactive, I should say, and also gamma rays. Do you know what is isotope?
It's a chemical element.
That's right. I think it's more in the chemistry, but somewhere in physics, that if you see that in your chemistry, you see that, for example, an atom, for example, imagine that, for example, a proton, for example, a hydrogen, or helium, or any material. The number of the protons, it's normally the same as the number of the neutrons. Am I right?
Yes.
That's what you have learned in chemistry, I think, correct?
Yeah.
Yeah? The number of these two things are the same. For example, the number of the neutrons with the number of the protons. If there are some sorts of, for example, let me give you an example. Philip, imagine that you have how many, let's say, let me think. How many eyes do you have? Two eyes, huh? On your face. Imagine that you can find some other people who look exactly like you. They have the same height, they have the same weight, they look exactly like you, but some of them they have 3 eyes, some of them they have 4 eyes. You see, you call them, this is your isotope. They are your brother isotope. You are exactly like each other. All of you are called Philip, but we have 4 Philips with the same height, with the same weight. 2 of them have one, you have 2 eyes, the other one has 3 eyes, the other one has 4 eyes, the other have 5 eyes. But all of you are Philip, the same characteristics. That's, you call them brother isotope. With the materials is like that. For example, you have one element of the periodic table with the same number of the protons. You can find the same elements in nature with the different number of the neutrons. The neutrons is not going to be equal to the protons. It varies. Then they create collectively the name of the isotope of that material. And that's why it gives that material unstability. That's right?
Mm-hmm.
Awesome. Any questions?
No.
No? Yeah, please go on.
So I think that's the last page.
Oh, okay. Thank you, man. Thanks. That was brilliant. Oh my God. Oh my God. It was like the radioactivity. Thanks for finding that clip. It's every atoms, every nucleus was giving rise to 2 other pairs. One alpha, one the other nucleus. It was good that you included that video. It was very relevant. Thanks. Okay. Oh my God. Thanks a lot, Philip. That was brilliant. And I should say those 3 videos that you included, the first one with that very nice I should say, music with the new nice image. The second one, which called the ambulance. And this one, it was phenomenal. Thanks. It was very artistic. And that's good that you're going to your art because you are so creative to create something. That was brilliant. Thank you very much. It was so creative. And I think if you go to the art, you are going to do a great job. You can be an art, you can be a creative director.